So let's get quickly started with the agenda for the session today. I'm going to be talking about what competitive coding is, what are the advantages of participating in coding competitions, what are the various popular coding competitions that happen in India as well as globally, some preparation guidance for coding competitions, and how does participating in coding competitions help improve product placements. So when we are talking about product placements, I'm particularly talking about placements in dream offers as well as super dream offers. See, generally today students talk about jobs that pay annual salaries of 5 to 10 lakhs per annum as dream offers and salaries upwards of 10 lakhs per annum as super dream offers. So how does participating in competitive coding help improve product company placements? And we're also going to be talking about preparation for Code Beta. Now that Code Beta is expected to happen sometime in late June, that's more or less like an expectation. But how do we kind of start preparing for that? Are the things that we're going to be talking about in today's session. Now, what is competitive coding? Now, competitive coding is a mind sport which involves programming. Now, when we say it's a mind sport that involves programming, right? There are programming questions that are asked in the competition. It might be math-based questions, puzzle-based questions, or real-life scenarios, but that will involve programming skills to solve the problem. Okay, and there are a set of questions that are given, and depending on who does well, there are winners who are selected for the contest. Now, you will have to understand this more like a spell bee kind of a contest. Now, spell bee is a competition that we are all familiar with, right? So in spell bee, what happens? There are multiple levels that you have, and students tend to participate in the spell bee competition. So people who clear rank round 1 go to round 2, then they go to round 3, round 4, and so on. You have a finals, and then ultimately people who are able to spell the toughest words in the finals are the people who win the contest. Now, one thing that has happened is, while it helps you understand and identify people with good spelling skills, it's also helped create a culture where a lot of students understand the importance of spellings, and they look at the whole competition as a fun way for them to participate and start picking up spelling as a skill, right? It's a fun and interesting way of doing it. Similarly, you have coding competitions that happen across the world. Now, there are two major advantages here. One is it kind of helps us identify people with solid coding talent. Second, it also is more like a sport where people kind of enjoy participating in it, and the participants eventually build up strong coding skills. Now, the first coding competition that happened globally was ICPC, Inter-College Programming Challenge, that originated in the 1970s. That's considered as the oldest one. And 1970s, 80s, we did not have the advent of internet, so this was happening more like an event where people had to come to a physical place. Now, from the 2000s onwards, right, most of these competitions have been happening as internet-based online competitions. And the interest really started picking up in 2000s and 2010s, where you had the revolution of the internet age companies, and these companies started paying crazy salaries to their developers, and they were hiring based on their programming skills. Now, coding competition was one of the strong ways for these companies to identify serious talent when it comes to coding. Now, today you have hundreds of coding competitions that happen throughout the year. And most of these coding competitions are actually conducted by potential recruiters. So, for example, Google has its own coding competition. Facebook has its own coding competition. ICPC is sponsored by IBM, and so on. Yeah, like what I already said, in each round, a set of mathematical or logical problems in the form of puzzles are asked for students. Now, these puzzles, right, are asked on a platform where there are certain test cases given. So test cases, we will have a sample input and a sample output. Okay. Now, there are a few visible test cases and a few hidden test cases. Visible test cases are the ones that students can see. So they always optimize their program for the visible test cases. Hidden test cases are the programs that students will not be able to see, but they will have to optimize the program for all the given constraints. So after a student kind of writes the program and he compiles it, right? They pass all these test cases and see how many of these test cases are passed. Students are kind of given marks based on the number of test cases that they pass. Okay, ultimately ranking in the competition is decided based on the number of questions they would have solved, the number of test cases passed, the time taken to write the code for a particular question, and things like that. Now, in these questions, right, normally they kind of expect students to work with large amounts of data. So these solutions are expected to be time optimized as well as space optimized. So what do we mean by time optimized and space optimized? Basically, it's the server time that it takes to run the program and how much of server space it's taking to store values, right? So normally we talk about order complexity, big O of n. So you expect the programs to be optimized for time as well as space. Now that's the larger challenge here for the students, because mostly what happens is the visible test cases will have very small numbers. Now, even if the code is not optimized, it will still be able to pass the visible test cases. But the hidden test cases is where the large data values are kept. And if the students are not able to kind of write an optimized code, they will not be able to pass some of these values. Now, this is something which is very important for students to keep in mind. That's why learning data structures and algorithms becomes very, very important. Right. So why take up competitive coding? So one of the major reasons is today recruiters use this as an opportunity to identify talent. So students who go on to win in competitive coding competitions, or students who kind of go on to even qualify for the final rounds, etc., are people who tend to get direct interview offers with these recruiters. So that is one of the direct motivating reasons for students to take up competitive coding. The second thing is, because in competitive coding, right, you keep solving problem after problem, and you do this in a fun manner. So just imagine if you're going to ask a student to start learning programming as a skill, and he kind of starts practicing, he kind of starts learning the concepts, and there is no obvious goal that kind of motivates him to continuously keep studying, then he's not going to put in a lot of effort towards continuously improving the skill. But in competitive coding, what happens? There are a lot of competitions that you typically keep participating. So a student who is serious about competitive coding kind of starts preparing for it. In some colleges, it happens as early as first year. In some places, students start from the second year. So typically by middle of second year, students have learned basic concepts and they start participating in competitions. So second year, they kind of give it a try. Third year, they're more serious participants. A lot of people start winning late in third year or late in their fourth years. That's when students get really good at competitive coding. That's because you need to spend a lot of time in terms of practicing, right? So just imagine how strong their technical problem solving skills would have evolved if over a 2-year period, they're participating in multiple competitions. And students typically tend to participate anywhere between 15 to 20 competitions in a year. So they target these competitions, they continuously keep practicing for them. So eventually their skill keeps improving. Now these improved skills are the same skills that are required in technical interviews. See, if you look at the recruitment drive of any IT service company or product company, the toughest round in the entire recruitment process is going to be the technical coding round. Today it happens on a HackerRank or a Hacker Earth or a similar platform. Now what happens there? There's a question which is given to the students. There are visible test cases, hidden test cases. The student has to write a program which will be able to pass all the test cases. Now that's exactly the same thing that students do when it comes to competitive coding also. But the level of questions that students face in competitive coding is much, much tougher. So naturally, when students have gone through this level of preparation, they will find their placement drives or the questions that are asked in placement drives to be way more easier. So naturally, these are the students who tend to crack the technical interviews. And like what we already discussed, this is organized in the form of a sport, right? So the whole gamification does not kind of allow the students to get fatigued with practice, and they continuously keep practicing these questions in a fun manner. Now, participating in coding competitions helps improve the enthusiasm level for students in computer science education. See, basically there are two particular extracurricular skills that we would expect students in computer science education to pick up. One is competitive coding, where their problem solving skills will continuously keep improving. And the other thing is their ability to build applications also has to develop. Now, for a well-rounded computer science engineer to be kind of passing out by the time he kind of completes his graduation, we would want him to have both these skills side by side. One, he should be good in competitive coding. Two, he should be good in development. So how does he kind of illustrate his good development skills? He picks up his ability to develop products, right? So he might be a Android app developer, an iOS developer, a web developer, full stack developer. Whatever development area he kind of wants to specialize in, he picks up skills. He starts developing products. He starts participating in hackathons to demonstrate his ability, right? So competitive coding overall helps students improve their love for computer science education, which in turn helps them put in more hours of practice and evolve as better computer science students. So some of the popular coding competitions, like what we saw, ICPC, which is now rebranded as ACM ICPC, is the most popular contest in the world, right? These are global contests. Google conducts 3 contests in a year: Google Kickstart, Hashcode, and CodeJam. And Google hires through Kickstart as well as CodeJam. Now, if you look at Kickstart as a contest, right, it happens in 8 different rounds, and each of these rounds are independent rounds. So it does not mean that you need to qualify in round 1 to participate in round 2, right? Each of these 8 rounds are independent, and there are winners for each of these 8 rounds. And students who do well in any of these 8 rounds are kind of given interview opportunities with Google. Now, ACM ICPC is more like a hierarchical rounds. So it's like you have 4 zones in India. So you have a zonal round, then you have a national round, then you have international rounds, etc. And in each of these rounds, right, only if you qualify in one round, you go to the subsequent round. There are a lot of competitions where you have a very hierarchical way of participating. So for example, TCS Codevita and Hack with Infi are 2 of the very popular contests in India. TCS Code Beta was in the news a week or 2 weeks before, where it kind of won a Guinness record that you had the highest number of students participating in a coding competition. Now, interestingly, right, for TCS Code Beta last year, we had around 3.42 lakh people registering for Code Beta, right? 3.5 lakh people. Now, I thought that's a great number. But then when I read about this Guinness records, right, the number of people who have participated is only about 1.3 lakhs, plus or minus 5,000. And I'm giving you rough figures. But then if you look at the participation rate, so at 1.3 lakhs, that was the most contested coding competition. But then the number of people who participated in it is just about 1/3 of the people who registered for the event. See, the first 3 are international competitions, extremely popular globally. Now, you also have events where people participate as individuals. For example, TCS Code Beta, people register and participate as individuals today. But whereas Facebook Hacker Cup is a group event, students participate in groups of 3 members, right? So I think something that would have been clear for you by now is there are multiple formats in which competitions happen. So there are events where students participate as individuals. There are events where students participate in small groups. When I say small groups, it's typically 2 or 3 people in it. Second, there are certain competitions which have rounds. Like Kickstart is one of the events where you have multiple rounds, but each round is independent of the other. But in most of the competitions, it happens in a hierarchical manner, where only students who clear round 1 get to go to round 2, People who clear round 2 go to the subsequent round and so on. Typically, you have 3 to 4 rounds in each of these competitions. The last round is the finals. And normally finals, right, you have only about 100 or 200 people attending. And before the outbreak of COVID pandemic, the final round used to happen in one physical place, and students were all taken to the particular place, right? So people used to go to Google offices, people used to go to TCS's office, Infosys's office, and so this was a massive opportunity for people to go and experience life in these companies, plus also participate in the coding competition. Now, the duration of the competition again varies. The shorter competitions happen for just about a couple of hours, and the longer ones happen for even 24 hours or even kind of a whole week. Now, TCS Code Beta happens for 6 hours. Google Kickstart is a 3-hour competition. Hack with Infi is a 3-hour competition. The typical times would be between 3 to 6 hours. Now, in addition to these companies and the established coding competitions per se, there are also contests that happen on platforms such as HackerRank, HackerEarth, CodeChef, TopCoder, etc. Now, these are platforms which kind of serve as a practice platform for students. Plus, these are the platforms that recruiters also use for recruitment. And they kind of, as a part of their community building initiative, there are a lot of practice puzzles given for students. There are a lot of coding competitions that happen. Now, normally in these coding competitions, one major advantage is you have certain sponsors for these events, and some of these sponsors do tend to recruit people who do well, right? So, advantages of coding competitions, like what we saw, it helps students improve their programming skills. There are certain competitions from which recruiters directly hire. Even if it does not happen, the programming skills of students will substantially improved, which will help them crack recruitment drives of product companies. And more than all these things, students who win in coding competitions earn extremely valuable resume points, right? So if you've been a TCS Code Beta finalist, or if you've cracked round 1 of ACM, ICPC, etc., these are very, very strong resume points. So for students who happen to attend interviews from there on, right, the interviewer is going to look at them with a lot of respect. Right. So what skills are tested as far as these coding competitions are concerned? See, like what we said, these are extremely complex programming challenges that students are expected to solve. In round 1, the difficulty level of the challenge is pretty low. And as you keep going to subsequent levels, the difficulty level keeps increasing higher and higher. But straight away, a student cannot get started with preparing data structures and algorithms. Students will have to typically start learning programming skills with fundamentals of programming, where they start learning about input, output, operators, decision making, iteration and looping statements, arrays and strings. Are the basic, when somebody starts learning programming, these are the topics that students start learning. Right? In arrays and strings, because it's application of different concepts that they have learned earlier, you have questions that happen at easy levels, but you also have very, very complex questions which can be asked in arrays and strings, right? So students are expected to first learn fundamentals of programming or basic programming language, any one basic programming language, and these are the concepts that they should first master. Now, the important thing to remember here is when students learn a programming language, the language that they're going to choose to learn does not matter. So this is one question that I continuously keep getting. Which is a good language to learn? It really does not matter is the answer. See, extremely elite programmers, if you talk about the top 100, top 1000 competitive coders in the world, at their level, there is discussion around why Java is a slower language, why C++ or Python is preferred over Java. So, but then that happens at a very elite level. Typically for an engineering student who's just getting into programming, my view is between C++, Java and Python, any language is fine. And all the coding competitions across the world allow these 3 languages. Now, in addition to this, there are multiple languages that students are allowed. Code Beta, for example, allows around 8 languages in which students can code, right? So the language does not matter. How well you understand the language, how well you're able to master the nuances is what matters. When a student learns fundamentals of programming, the most important thing that you need to keep in mind is students should not learn with a syntax first approach, but rather they should learn with a problem solving first approach. So when we say problem solving first approach, what do we mean? First thing is they're trying to solve a problem. They're not trying to memorize a whole lot of syntaxes. No, a reason why a lot of students tend to hate programming is because there's so much of syntax dumping which happens on them right when they set out to learn a particular programming language. So don't do that. Let them kind of introduce problems to them. Let them first think of the logic that's going to be used to solve the problem, then get into coding. Whatever syntaxes I need to learn to kind of solve the problem, I pick it up. And then I keep learning syntaxes as I keep progressing in the course, rather than learning all syntaxes at first. The second thing is students should learn this hands-on. So which means every time he kind of learns a question, he has to compile the question, right? He needs to type it out, debug the question, compile it, pass all the test cases, and then go to the next question, right? If students do not get comfortable with coding hands-on, then that's not the right way to learn programming. After this, students need to understand the concepts of time and space complexity. See, without understanding time and space complexity, which is normally expressed with big O notation, students will not even find out whether their programs are optimized or not. So understanding time and space complexity. See, it's not going to take a lot of time to learn this, but then understanding this is very, very important because the programs have to be optimized for time and space. Then see, basically data structures. People from computer science department understand this. See, data structures are used when you handle large amounts of data. Algorithmic techniques are used when you have to kind of process large amounts of data. You're just optimizing the kind of time that the program is going to run. So these are just different data structures where you store data, and then algorithmic techniques that I've listed here. I'm not going to read them out. These are the most common ones. Typically, a computer science student kind of learns them in his core engineering curriculum also. But what happens is, in colleges, when data structures and algorithms are typically taught, there is a higher focus on theory than application of this, particularly in solving complex problems, right? So again, like what we saw in fundamentals of programming, when students learn data structures and algorithms, the focus should be to learn this in a hands-on manner, and they should solve a lot of questions. So they can solve this on any online compilers, or they can use a platform like your HackerRank, HackerEarth, or FacePrep's own proprietary platform. All these platforms are good enough. Pick up one of these platforms and start practicing in one of them. That's the most important thing. Right. Now, let's get started with what are the certain do's and certain don'ts when it comes to getting ready for preparing for competitive coding. Now, the first important thing is students should start early. Now, typically, right, I've seen this in a lot of colleges. People start preparing for competitive coding only at the end of their third year or beginning of fourth year. That's too late. The reason is, see, obviously that's when a lot of computer science education would have also got completed in the college, because typically in the first year, common engineering, as in the common science papers is what students study, with just one or two computer science papers, right? So kind of they learn computer science in second year, third year, and then they kind of start participating in competitive coding only in the fourth year. That's too late, because in the fourth year, beginning of fourth year, is when students will start kind of preparing for their campus placements also. They have certain soft skills classes, they have certain aptitude classes, etc. And they really don't focus on competitive coding the way they ought to be doing. So when I say start early, now people should typically be looking at completing fundamentals of programming training right in the first year itself. Typically second semester would be the ideal time for students to do it. First semester is when students are busy settling into the college. Third semester, that's beginning of second year, is when students should learn data structures and algorithms. Now, both these courses, please ensure that when you train your students, you're training them on a hands-on manner, right? There should be dozens and dozens of questions that students should be solving every week. That's the right way to prepare. Now, after students have kind of learned fundamentals of programming, data structures, and algorithms, they need to do a lot of practice. So what do we mean by lots of practice? Students can kind of enroll themselves in any of these open platforms that we discussed. Pick up questions, keep solving them. Like somebody who's very serious about competitive coding is typically expected to spend 10 to 15 hours every week, which typically translates to 2 hours on a daily basis. 2 hours every day is not possible, but a weekly 10 to 15 hours is the required effort. Now, sustaining this practice is the difficulty that a lot of academicians, training and placement officers will face. How do you do that? And one more thing, you don't expect all the students in the class to do this also. Very honestly, right? Uh, like you find a certain number, probably that number could be between 30 to 60% of students in computer science and IT departments who will be interested in doing this. So it's important to sustain the momentum and continuously keep challenging students. One way of doing that is forming coding clubs in the college. So these coding clubs can conduct a lot of intra-college events. So within the college, they keep conducting events on a weekly basis or a monthly basis. People who do well are kind of recognized. It's the recognition which will keep motivating them, because when somebody just gets into competitive coding, right, whatever national, international competitions that they go and participate in, chances of even qualifying for the next round is going to be very less. For people to get to that level, it's going to take at least 1 year of serious practice. So for the first 1 year, how do you maintain momentum is going to be the larger challenge. So forming coding clubs within the college, conducting a lot of events, recognizing people who do well, organizing continuous training programs. See, initially people think they've understood all about data structures and algorithms. But then only when they kind of start practicing, start participating in competitions, they understand the shortfalls that they have. Okay, I know X amount of content, but then I need to learn more. This is a concept that I've not practiced enough, right? So conducting these events, helping students understand their weak areas is something that we should continuously keep helping our students with. So the first 6 months or 1 year after they have learned data structures and algorithms is going to be the most critical period. Now, if you're able to keep them engaged over the next 6 months to 1 year, then what will happen is they'll start enjoying the sport. They'll start enjoying participating in competitions, analyzing how they participated in competitions, kind of gearing up for the next competitions. Now, once that interest level sets in, right, then life becomes easy for us, because that interest will continuously keep motivating students. Now, interestingly, this is more like forming a coding culture in the college. Now, today, if you look at IITs and NITs, right, they kind of corner a vast majority of the IT product company placements that happen in India. Now, how does that happen? It's not something that happens by chance. It happens because, one, obviously students who go and join these colleges are very good. Now, that's the reason why they would have got admissions there. But they also have this culture in the college. See, today, a student who walks into the college in the first year looks at people who are getting wonderful placement opportunities in the final year. They look at students who are celebrated in the final year. Now, these are guys who have participated in coding competitions. Participating in coding competitions, and that's where you find a lot of winners from India emerging from. And they also find that these guys are getting placed in companies with amazing salary packages. So they kind of understand that, okay, this is the path that I have to take in my 4-year education. And when they interact with their seniors, they know that these seniors started preparing right from the first year. So this guy knows that if in the final year he needs to get there, he has to start his preparation right from the first year, right? So they kind of look at their seniors, observe their seniors, and learn from their seniors. Now, if we are able to set a similar culture within our college also, right? So the first batch is going to be the toughest. Sustaining interest level for the first batch, getting them ahead and getting them to kind of do well in the competitions and get some good placements. See, if they're able to sustain interest and learn over a 4-year period, trust me, they will. You'll have certain stars emerging in the first batch itself. Now that becomes motivational case studies for the juniors, and then this culture will pick up within the college. So you'll have the seniors running the coding clubs. Juniors start getting into coding clubs right from first year. They understand the importance of starting to code early, and then probably there's nothing which can stop us once we're able to make this a cultural thing in the college, which is what I think ideally each of us should be targeting. Right. So how does competitive coding help students get placed in product companies? Now, these are, I'm just summarizing whatever I've discussed earlier, because by now you would have understood that what happens in competitive coding is very similar to what product company recruiters are looking at. See, ultimately, product company recruiters are looking at students with very strong problem solving skills. One. And the second thing is they're looking at students with good programming skills, right? These two things are exactly what is evaluated when students participating in coding competitions, right? So students who participate in coding competitions would have built very strong programming skills, very strong coding skills, and hence you will find that these students do extremely well in the product company recruitment rates. Even in the second round, after they clear the coding round, they have an interview round. Typically, interviews used to happen as whiteboard interviews earlier. Now they've started doing a code share interview. See, basically, whiteboard or code share interview, what happens is there's a problem which is again a programming puzzle which is given to the student. The student is not expected to solve the program and pass all the test cases here. Here, what happens is the interviewer tries to evaluate the student based on how he approaches a particular problem, right? So whatever thoughts that the student has, he kind of shares it with the interviewer as he goes on solving the question. Now, these are things that competitive coders would have done with their peers, because in a lot of cases they work in teams, they try to solve it together. They explain their point of view to their friends with whom they are solving puzzles, right? So these students find even these interviews to be a cakewalk. So if a student starts preparing for competitive coding and he kind of really prepares for it over a 2-year period, he will find product company placements to be way more easier, because the questions asked in product company placements are significantly of a lower difficulty level than what he endures in coding competitions. So ultimately, serious participants in coding competitions will find product company placements to be a breeze. Now I'm going to talk about TCS Code Beta. Like what most of you would be familiar with. TCS Code Beta is a coding competition that's conducted by TCS. It's a global coding competition. Now, this year it's going to be the 10th season of TCS Code Beta. Now, this is expected to happen by probably end of June. I'm sorry, end of July is when it's. I'm sorry, it's expected to happen by end of July. Probably we'll expect the announcement to kind of come out in the next week to 10 days. Once the announcement comes in, students might have a 2-3 week window to register. And from there on, they'll at least have a month to 45 days to prepare, right? So end of July, so even if students are going to start their preparation from now, they will at least have 2 months to prepare for TCS Code Beta. Now, TCS Code Beta is a global coding competition. For example, last year in the top 3 spots, right, we did not even have one Indian student. I'm talking about the finals. But then see, there are 2 reasons why students participate in TCS Code Beta. One, to kind of become a podium finisher, and there is significant cash prize to be won, right? $20,000 is the total cash prize which is given. But the other thing is, students who perform well in the first round itself will be rewarded with direct interviews. So a lot of people participating in TCS Code Beta look at this as an opportunity to get an interview call with TCS. Now, the direct interview calls, the role is not specified. Depending on the interview performance, students can get an offer for TCS Ninja as well as TCS Digital. like what you might be aware, TCS Digital typically pays salaries upwards of 6.5 lakhs per annum. It's around 6.5 lakhs per annum, right? So it gives students an amazing opportunity to get a job offer with TCS, and these students who kind of do well in the first round get a direct interview call. They don't even have any subsequent programming or aptitude rounds. The next reason is obviously TCS Code Beta. The questions asked are tougher. This is a coding competition. Typically, the difficulty level of the first round of TCS Code Beta is tougher than the interview questions that are asked in IT service companies, right? The questions that are asked in IT product companies are slightly tougher than the questions in first round of TCS Code Beta. But then definitely TCS Code Beta questions are way more tougher than the first round of your your IT service companies, like for example TCS or whatever questions that might be asked by Wipro or similar recruiters, right? So definitely preparing for TCS Code Beta will help students be prepared for subsequent placements. Now TCS Code Beta, by virtue of happening by end of July, right, will happen before any other IT service companies placements happening. Probably that might just be the time when IT product company placements also start picking up in a lot of colleges. So preparing for this is a good opportunity for students to be prepared for campus placements in general. Now, because the difficulty level of the first round is moderate, it's a good opportunity for students who are even starting their preparation to be prepared. Like what we said, students have at least 2 months time from now on to be prepared for Code Beta. So if there is a student who does not even know fundamentals of programming, somebody is going to just get started with preparing through fundamentals of programming, even they will find that there is sufficient time for them to be prepared. Now, typically we find most of these registrants and participants to be from the final year, which is naturally understandable because from a college side, there's a lot of encouragement from students for the final year students, because that's where the placement opportunities, which is our immediate area of interest, is available aplenty. But I think we should take a slightly longer term view on this, which is how do we build a coding culture in our college? Now, by the time my first, second year students, when they come to their final year, how do I look at improving the number of product company placements? See, it's not possible to improve the number of product company placements by helping students prepare for like 6 months or 1 year. Students will need at least a 2-year window to be solidly prepared, right? So I think this is an amazing opportunity. And students also have this tendency to kind of start working only when there is an immediate goal in front of them, right? So TCS Code Beta could be a good goal for students even in 2023 and 2024 batches to start preparing and participating. While students in the final year typically get interview calls, students from second, third years, right, when they participate in Code Beta, they get internships with TCS if they happen to do well, right? So this is an amazing opportunity for a student. If a student in his second year, third year can crack the first round, I think he would have done good for himself, and he's the guy who will take up competitive coding seriously and start preparing from here on. So we should look at encouraging students from second as well as third years. When I say second and third years, I'm talking about people who are now about to finish their first and second years. That's students who are going to be graduating in batches of 2023 and 24 to participate in this field. So how do you go about preparing them? So yeah, my view is 45 days is good enough time to prepare for Code Beta. But when I say 45 days, I'm talking about 3 hours of solid preparation on a daily basis. So first thing is students will have to pick up a coding language and learn fundamentals. So like what we said, any coding language is fine. If students already know one particular coding language, they can just stick to it. Typically for competitive coding, we kind of recommend students to start with C++ or Python if they have not started any particular language. The reason simple. C++ is a very basic language which is just like an extension of C. Most people would have learned or started with C. So C++ is that way is an easy language to learn. Python is a higher level language. The syntaxes are very simple. It's very close to the English language that we speak. So that's the reason why we kind of recommend these two languages. If students know one of those languages, they just have to stick to it, but they need to do a lot of practice, right? See, students typically would have learned a programming skill only at a very basic elementary level. They would have just solved a few questions and they think they've understood it. But then this requires a lot of practice, right? So students will have to keep practicing. Loads and loads of practice is what will help them build the required skill. Now, while I've not put it on the PPT, after learning programming fundamentals, students will definitely have to learn data structures and algorithms. See, typically TCS Code Beta is a 6-hour long contest and students are given 6 questions to solve it. While we don't have last year's statistics, the year before, that's season 8 of Code Beta, which happened in 2019, sorry. Now, the students who cracked round 1 were people who solved only one question. Out of 6 programming questions which were given, students who solved just one question cleared round 1 and went on to round 2. And that year, everyone who cleared round 1 was also given an interview call. So, basically back then, awareness around coding competitions was less. But today, awareness has gone up, preparation levels have gone up. But then it's still not very difficult, right? And if you look at the 6 questions, right, 2 of these questions which are given in Code Beta are still very elementary in nature. So someone who just masters fundamentals of programming up to arrays and strings will be able to solve 2 or even 3 questions. But then the other 3 questions will definitely need sound knowledge of data structures and algorithms, right? So after students learn FOP and they've done sufficient amount of practice, then they should also definitely look at picking up data structures and algorithms. But no point in trying to learn data structures algorithms without developing sufficient proficiency in fundamentals of programming. So once preparation is done, students will have to participate in simulated mock contests. And see, basically like what we said, out of 6 questions, students are typically looking at attempting 2 to 3 questions. Now, you need to pick up the questions that you will be able to solve. In some cases, a student picks up a very difficult question and spends about 5 hours trying to crack that question, and even after 5 hours, he's not able to do it. We've seen multiple cases like that. Whereas we found the smarter students to pick up the easier questions. They would have solved a couple of easy questions in the first 3 hours. So smartness around picking up questions is important. Students can do that only if they participate in simulated mock contests. And finally, we would definitely ask students to also look at the previous year's TCS Code Beta questions and prepare for that also. Now, these questions are available on our Face Prep site as well as on our Face Prep YouTube channel, right? So if students want free resources to prepare for Code Beta, it's available on our Face Prep website as well as our Face Prep YouTube channels. Students can make use of that. But if you need any further help in terms of trying to understand more about competitive coding or about product company placements, we're always there to help you. I've put my email ID on the slide. Please feel free to reach out to me if you need any help in terms of improving the coding skills of your student. Even if you want some guidance in terms of how to run a coding club in your college, or you need some help to kind of set it up, please reach out to us. Yeah, with that, I'm done with my presentation. I'll be happy to take any questions that you might have. Okay, I've got a question. Any idea when TCS NQT might happen? See, this year we do not concretely know when NQT is planned, but based on whatever interactions that we've had with people whom we know in the industry. We strongly believe it will happen sometime in August. Probably early August is when TCS Digital might happen, and late August, mid to late August is when TCS NQT might happen. But then again, at this stage, right, even the organization company does not have solid plans, is what we understand, because the COVID situation is still a little fluid and things are emerging. So when there is more certainty around it is when it's going to be planned. But I think we should get our students prepared for TCS NQT, keeping in mind that that could happen sometime in August. I'm sorry, it's going to be a little difficult for me to unmute you on the presentation. So if you have any questions, I'll request you to type them in the chat window. Right. So I have a question about other companies' hackathons. So like what I said in India, so Virtusa's Neural Hack, Infosys Hack with Infi are some of the popular competitions. Globally, like what I said, Google Kickstart. This year it has started. I think they're already in round C. There are round C is the third round out of 8 rounds that happens. Uh, so if you just Google for popular coding contests, right, you will get a list of it. We will also try to come up with a compilation of popular coding contests and how students can register for it. And in due course of time, we'll share that also with you. Yes. Yeah. For people who are asking me for a summary of whatever we've discussed today or PPT, the entire recording of this presentation will be shared with you, right? You will receive a email in some time. You can use the this thing video to kind of go through it again if you missed parts of it or you want to revisit certain parts. Right. Generally, which year is best to prepare for TCS Code Beta? Naturally, the final year students should be taking up Code Beta immediately, because obviously it kind of helps them get prepared for other company placements, as well as it gives them an opportunity to secure a direct interview round. But I strongly recommend even the current first years and current second years should look at participating in Code Beta this year. See, we don't expect them to win, but then we want them to understand what a coding competition is. We would kind of see, now if TCS Code Beta is going to happen in a couple of months from now, right? Students don't have a choice. They'll immediately kind of start preparing. They'll at least learn fundamentals of programming. They'll participate in the event. It kind of makes them understand what a coding competition is. And once they participate in the event, they really know where they stand. So it kind of knocks out the lethargy in them and they kind of start preparing seriously. Right. Okay. See, we do offer training programs for this thing, TCS Code Beta. If you have any specific queries on that, what I will do is some of you have asked me specific questions. I will kind of write an email to you, or I'll ask somebody from our sales team to get in touch with you on that. Or you can just drop me an email and I'll connect you with my sales team person. Right. So yeah. So I've got a query about how do we prepare students for opportunities like Goldman Sachs, Google, and others which pay about 10 lakhs per annum. Like what you have already correctly pointed out, sir. So we need to train students on fundamentals of programming, followed by data structures, algorithms, and take them through lots of practice. Practice is slightly different when it comes to preparing for coding competitions, and slightly different when they participate in these companies that you have mentioned. See, in addition to these companies, there are loads of other companies. So, for example, Disha, Flipkart, Amazon, Microsoft are companies that a lot of people do not think about. But these are the probably recruiters who make maximum number of offers in the about 10 lakhs salary package in our country. And these companies have very specific ways of testing students. So what we should typically do is after the first and second year where we train them on FOP and data structures algorithms, second, third year we help them practice for competitive coding. Beginning of fourth year, we help them practice for these IT product companies, the companies that we just spoke about. So that's how we do it. I will get in touch with you, sir, with more specific details. Yes, ma'am. We have a company-specific training program for this thing, TCS Code Beta also. We have a only online course which is priced at a very affordable price point for students. We also have a offline course plus an online course which kind of helps them with access to trainer also. I will send you all these details, ma'am. Right. So I've got a interesting question. IT computer science students will be able to prepare easily. What about non-IT, non-computer science students? So the way it gets positioned is typically what we've also observed is ECE students also find it easier to prepare. So ECE computer science IT students find it easy to prepare. Other departments find it a little challenging. Now, what happens is particularly if these students start getting into preparation only in the final year, it's going to be a little challenging, sir. But if you're going to start this right from the first year itself, then it gives us enough opportunity to kind of get them prepared. So when I say first year, the way we introduce programming to them, somebody today in a civil or mechanical department asks this question, I'm not a computer science student, so why should I learn this? So the way we kind of introduce programming to him is how programming is more like the new computing skills. Probably 10, 15 years back when we were graduating, we were looking at skills like do you know how to operate a computer, do you know MS Office, do you know how to send an email? Those are things that you needed to get your first job. Now with industry 4.0, everyone needs to know programming to get a good job or to kind of do well in their jobs. With that context being set right at the beginning of probably second semester or second year, we kind of typically start training students on these skills. So these skills are trainable as long as we start early, and even if they come from any different background, we will be able to train them, sir. But it takes a little bit of time. Starting in the final year is going to be very challenging. Do we have a platform that can be given to students from the first year? Yes, sir. We have a platform. So our complete training happens platform based, so that students have sufficient time to practice. So we have a platform which at the first year level, it's a the kind of questions that are put on the platform are very, very elementary, and the solutions are also given in a very basic level so that somebody who's very new to coding can also pick it up. And then the difficulty level keeps increasing as students spend more time on the platform. We definitely have that, sir. Definitely, sir. So I have got a suggestion about making sessions more interactive with students in hands-on problem solving, giving them goodies and practice tests. Definitely, sir. I take your feedback on that, and we'll definitely work on that aspect to make the classes more interesting and interactive for students, sir. So computer science and IT students are in the same training session along with EC and Triple E students. Non-IT students are not catching those concepts properly equivalent to computer science students. Very true, sir. This is a problem that we face in a lot of colleges when we do training. But what happens, see, typically what we recommend is trying to do a assessment of students, because what happens is even in EC you have some students who are brighter than some computer science IT students, sir. So typically I personally think we should try to kind of segregate students into multiple batches depending on their skill level rather than which departments they come from. So we normally do a diagnostic test at the beginning of a training program and then accordingly segregate them into different batches. So that way it becomes a little easier because students of similar skill levels are there in each area. So with that, I've taken all the questions that have come in. If there are no other questions, I'll be, yeah, we can close the session. What I'm doing is I'm typing my phone number and email ID. I'm sending it to all of you. So in case you have any queries or anything that you would want to ask me, please feel free to reach out to me on this phone number and email ID. Right. So I've got an interesting question. Competitive programming is not the only skill that a product company looks for, correct? What you say is partly correct, sir. So obviously, recruiters want students to be slightly more well-rounded. Now, this again depends from company to company, sir. For example, if you look at some of the established companies, right, they have a bare minimum requirement of students to be very good in solving program. So basically, what students are doing is technical problem solving. So they want students to be that's exactly what gets tested in competitive coding also. So they want students who are very good in technical problem solving. That's like a bare minimum. If students don't crack that particular round, students do not even get qualified for other rounds. Now, once students qualify there, after that, what do companies look at is different, sir. For example, uh, let's say there are certain companies which have amazing training programs to train students on skills that they want their students to be good at. Right? So those companies will train their students on those technologies and then they'll put them on the job. But some kind of a development experience is always appreciated. And students typically who kind of get started with competitive coding build some development experience. They might kind of start developing Android apps, iOS apps, or some full stack development projects they take up. And they put it on their Git profile and they also tend to showcase it. We kind of guide students on this also because that kind of shows that they're not kind of focused only on competitive coding, but they're also focused on development and they have a keen interest in development also. So this is something that happens side by side. But if you look at some of the startups, they might not have enough bandwidth and budget to train students on the particular skill area that they are looking at or the particular language that they are looking at. So in such cases, they expect students to also be proficient on what he's going to be working for in the company. So that's why you find companies which are as specific as asking for people who are good in Angular, people who are good in React, people who are good in Java full stack development, etc. So typically those are companies which do not have a training program. They expect students to come in with training program. So in such companies, a particular language or a particular skill requirement might also be there. But either ways, a short answer would be students need to have technical problem solving skills to even get an interview with any of these companies. So that skill is a must. On top of that, other skills may or may not be. System architecture is an amazing skill to have, sir. But then I find that system architecture, students are just expected to understand the basics. Where if they get, in certain cases, they get some interview questions from system architecture, which they should be able to answer. But then we hardly find 10-20% of the interviews to have questions from systems architecture, sir. All right, I've overshot the time by 15 minutes. I thank you all for being patient during the session, and I again apologize for the delayed start. I had a great time interacting with all of you. If you have any queries, please feel free to email me or call me. I'll be happy to help you. Thank you again. Bye.